Hello guys, this is question 9 in the multiple choice from an extension 1 semester 1 past paper from 2012 at Barker College. And it's a circle question that involves something called the inscribed angle theorem. And just off the bat, I'm going to say it now, next door neighbours are doing renos, it's bloody noisy, it's keeping me up at night, so I'm sorry if you can hear it in the background, nothing I can do about it. Anyway, so the question is, I'll read it first. Consider the 4 cyclic points A, B, C, D for the circle O. So 4 cyclic points just mean they're on a circle. And which of the following statements is true? So we've just got a bunch of statements here. And we've got to pick the right one. So I'm going to talk now about the inscribed angle theorem, because that's the theorem we're going to use in this question. And I've got this diagram off Wikipedia here. And what it's showing is, if you've got this base in a circle, so I think this is called a secant, or no, it's called a chord. Anyway, it's I'll look it up now. Hang on. Beautiful. I've just looked it up. It is a chord. A secant is something if it keeps going all the way through. So if CD was extended. Anyway, so if you've got this chord here, CD, and a line is drawn to B, and it's going to make this angle alpha. Now we use that same base again, CD, and draw a triangle to somewhere else on the circle, and what we get is this inscribed angle, which is also alpha. So whatever triangle you draw, I could draw one like, I'll just get my pen out, one like this. Alright, so it's going to be a shocking drawing. One like that. Because this CD is still the base, then this angle in here is going to be alpha. And just something as a bit of a side note, Danny, you might have seen this before. If you've got a diagram like this, a circle, and this is AB, the base, then when it joins at any point up here, so say we'll call this C and this D, when it joins at C and the base is the diameter, it's going to be a right angle at C. And according to the inscribed angle theorem, it's also going to be the same angle. These angles have to be the same at D and C because they've got the same base. But this is a special case because when the base is the diameter, it's going to be a right angle. So this kind of rule down here where you've got right angles because the base is the diameter is just a special case of the inscribed angle theorem up above. So I've drawn this diagram over here, which is relevant to question 9, and in this question I've made the base AB. So this is the base here. So that's our base. In this case, it's kind of equivalent to CD, and you can tell. So this is the diagram that I've drawn here, the base, and this angle ACB is alpha, and because we're using the same base AB, when we draw a triangle to another point at D, it's going to be the same angle. So this angle here, ADB, which is this little alpha here, will equal angle, this one here, ACB, according to the inscribed angle theorem. And that example is just this one here, D. So, yep, so that's why it's D, according to this inscribed angle theorem. So you could, the method for working this out would be you go, okay, DAC, you'd start off with a DAC equals CDA. No, definitely not, because in this case CDA is a right angle and DAC is something acute, so it's definitely not going to be that option. And you'd probably just go through a few of them, find the options which are plausible, which it could be, and then think about a few different theories that in this case the inscribed angle theorem would be the one you use to find the answer D. Alright, well I hope that was clear guys. I'll see you in the next vid.